I am Dr. Om Prakash, and today we are going to study about analysis of variance that's called anova. Anova is used as a test of means for two or more populations. The null hypothesis typically is that all means are equal. There are certain conditions that must be met to use ANOVA. Firstly, analysis of variance must have a dependent variable that is metric, that is, it should be either on interval or ratio scale. Secondly, there must also be one or more independent variables that are all categorical, that is, non-metric. Categorical independent variables are also called factors. Independent variable must have at least 3 categories. If it has less than 3 categories, that is, it has 2 categories, we use t-test instead of ANOVA. A particular combination of factor levels or categories is called a treatment. There are certain assumptions on the ANOVA. Generally, 3 primary assumptions in ANOVA are as follows. The responses for each factor level have a normal population distribution. These distributions have the same variance called homogeneity of variance. Thirdly, the data are independent from each other. Types of ANOVA. Basically, there are 2 types of ANOVA. One is called one-way ANOVA and another is called n-way ANOVA. One-way ANOVA has only one categorical variable or a single factor. In one-way analysis of variance, a treatment is same as factor level. N-way ANOVA, if 2 or more factors are involved, the analysis is called n-way analysis of variance. Two-way ANOVA is a special case of n-way ANOVA. If 2 factors are involved, the analysis is termed as two-way analysis of variance or two-way ANOVA. There are certain statistics that are associated with one-way analysis of variance. Firstly, eta square. It measures the strength of effects of x, that is dependent variable, on y, that is dependent variable. The value of eta square varies between 0 and 1. Second is F statistic. The null hypothesis that the categorical means are equal in population is tested by an F statistic based on the ratio of mean squared to x and mean square related to error. Mean square is the sum of squares divided by appropriate degrees of freedom. SS between, which is called between group sum of squares, also denoted as SSX. This is the variation in y. Y is dependent related to variation in means of categories of x. X is dependent variable. This represents variation between the categories of x or the portion of sum of squares in y related to x. It is also denoted by SST, that is sum of squares for treatment. Somewhere it is also written as SSR. SS within. This is called within group sum of squares, also referred to as SS error. This is the variation in y, that is dependent variable due to variation within each of the categories of x, that is called dependent variable. This variation is not accounted for by x. It is also denoted by SSE, that is sum of squares or error. SSY, this is the total variation in y, also denoted by TSS, that is total sum of squares. Conducting one-way ANOVA. There are certain steps we generally follow to conduct one-way ANOVA. First is, we generally identify the dependent and dependent variables. Then we further decompose the total variation into variation between and variation within. We measure the effects, then we test the significance, and finally we interpret the results. Manual calculation of one-way ANOVA. This is the table and the measurement should be shown in this table. We generally have 1, 2, 3, 4, 5 columns, and the first column we have sources of sum of squares, degree of freedom, mean of square, and for a statistic. So here the sources are between, group, or it is also called treatment. Then we have within group, or it is also called error, and we have total. Steps for manual calculation of ANOVA. There are certain basic steps that we should follow to calculate ANOVA manually. And number first is we calculate the group mean and grand mean or overall mean. Secondly, we calculate SSR. This is regression sum of squares or SS between using formula n summation xj minus x bar whole square, where n is the sample size of group J, Greek symbol summation, that means sum, xj the mean of group J, and x overall mean. Then we calculate SSC, sum of squares for error or SS within using the following formula. This is summation, this is xij, that is the ith observation is group J minus xj, this is mean of group J. We square it and then we sum up values. Fourth step is calculate SST, that is called total sum of square using the formula SST is equal to SSR plus SSE. Then we calculate degrees of freedom between and within group separately. Together we also calculate degree of freedom for the total. Between group of degree of freedom is equal to number of categories minus 1. Within group degree of freedom is equal to total number of samples minus number of categories. We calculate mean square for between and within group by dividing sum of square by their respective degree of freedom. Then we calculate F test statistic using formula MST by MSE. Then we compare F statistic value with critical value from F distribution table, and if F test statistic is greater than critical value, null hypothesis is rejected. That is, categories have not equal means. Otherwise, null hypothesis is not rejected. That is, categories have equal. So we have taken one of the example for manual calculation of ANOVA from a question that was asked in AKTU MBA examination in 2018-19. The question reads as, suppose a manufacturer of a breakfast food is interested to know the effectiveness of 3 different types of packaging. He puts each kind of packaged breakfast food into 5 different stores. He finds that during a given week, the number of packages sold were as follows. Packaging 1, and this is a store number 1. Packaging 2, this is store number 1. This is also store number 1 for packaging 3. Number of packages sold for the store number 1, 25. For store number 2, it is 28. Store number 3, 21. This is 30 and 26. The manufacturer would like to know significant difference among the mean values of all 3 packages. For this solution, we have to identify the dependent variable. Here the dependent variable is number of packages sold. This is metric data. Independent variable is types of packaging. This is non-metric. Independent variable is types of packaging and has 3 categories: packaging 1, packaging 2 and packaging 3. Therefore, we use one-way ANOVA, not t-test. Assuming all the 3 assumptions of ANOVA are met, we need to calculate SST, SSC, TSS, MST, MSE and F statistic. Step 1 here, we calculate mean for each packaging type and overall mean. So, mean for packaging number is 26, mean for packaging number 2 is 28, mean for packaging number 3 is 24, and grand mean, that is called overall mean, is 26. Then we calculate SST, that is between group of a square. Here again the mean is 26. Grand mean or overall mean is 26 and mean for packaging 2 is 28. Mean for packaging 3 is 24. Here the number of sample in packaging 1 is 5. Similarly, number of sample in packaging 2 is 5 and in packaging 3 it is 5. We calculate between group sum of a square. Here the formula already we have discussed previous slide, that the grand mean should be subtracted from the group mean and it is a square, then it is multiplied by sample size. Here the sample size is 5 and here the grand mean is 26. So we subtract this 26 from the packaging mean. So this is package 1 mean, that is 26. Similarly, we do for the packaging number 2 and packaging number 3 and the result is 4. Now we calculate SSE, that is within group sum of a square. For this we need to know the mean, and we have already calculated mean for the each packaging, that is for each categories of independent variable. Here packaging 1 the mean is 26, packaging 2 the mean is 28 and for packaging 3 the mean is 24. We calculate sum of a square for within group and for group number 1, that is packaging number 1, we calculated a sum of a square. Here we subtract 26, that is called mean, from each sample, that is here 25, 28, 21 and a square. Similarly, we do for the package number 2, for package number 3 and final result is, that is SSE is 144. Now we put the values in ANOVA table. Here we have source, between group and sum of a square we calculated as 40. For within group the calculated value is 144. For degree of freedom, since between group the categories is 3, that means we have 3 categories of packaging. From that 3 categories we subtract 1 and we get degree of freedom as 2. Similarly, for within group we calculated degree of freedom. Here the total sample is 15 and total number of categories is 3. So we subtract 3 from 15 and get. Now we calculate and the total sum of a square is calculated as the sum of between and within, and we get 184 after adding 40 plus 144. After calculating, we calculate mean square. Mean square is calculated by dividing the sum of a square between by their degree of freedom, and we get here 20. Similarly, for within group, 144 is divided by 12 and we get this 12. Now we calculated F ratio. F ratio is calculated by this MS between divided by MS within, and we get the value as 1.67. Acceptance and rejection of hypothesis. Here F statistics is 1.67. Critical value at 5% significant level is 3.8853, which is obtained from the F distribution table. Since F statistic, that is 1.67, is less than critical value 3.8853, we accept null hypothesis, that is all means are